Bravo Palla, grazie Palla. Pliger, sì, sì. Come sta andando? Prima o poi dovrà finire questo trend. Un sacco di gente.
Good morning. Welcome and welcome back to Track Lasagne. Our first speaker of today is Fabio Pliger, which is tech lead at S3 and Python developer since 2003. Fabio.
So, hi everybody, and thanks for coming. And my name is Fabio Pliger, and today I'll try to talk about optimization and testing. Mainly, I'll try to give you a point of view of the whole picture. Usually, we see a lot of talks talking about how to make things go faster, how to improve performance, how to run. Basically, this talk is a little bit different, and my goal is like to give you examples, to give you all the options you have, a lot of the options you have in the Python world to optimize and test, but focusing on why and when you should optimize and when you should not. So, title of the talk is optimization and testing, and without hurting yourself too much. So, I want to give you the roadmap of this talk, and I'd like to give you some introduction about me, about what I do, about why I've decided to give this talk, a little background, want to talk about testing, and then talk about optimization. So, who am I? My name is Fabio. I work at S3, which is a little startup I founded some years ago. And I've been programming in Python since 2003. I try to be very active in the Python community because I really believe it's an amazing community, and I like to interact and exchange ideas with other Pythonistas. S3 is a startup that works for the pharmaceutical industry, and which is a little bit important to understand the background of this talk. We work for big companies, and we do software for production processes, and mainly analysis applications that does some computations, reporting, and trends, and sort of things, but also that somehow controls the production line flow, which means for this industry, they have to run like almost every day all the year. And we have little windows where we can update, change systems, but it should run forever. And if like a big industry, pharmaceutical company lose half a day of work, it means like millions of euros. So better not have an angry customer in the pharmaceutical industry. So things should work. And so How many of you have been developing Python for like 1 year? Less than a year. Okay. 3 years. Okay. 5 years. So probably most of you are advanced users. And the profile of this talk tends to know how to program, how to use Python, and to know a little bit about what's under the hood. But I tried not to go too much into the details. So also people without a lot of experience can follow. And of course you have like time for questions. So this talk comes from my experience at S3, some experiences I had as a consultant, and many times when I talk to people and people ask help for improving their performance, many times they don't understand where they want to improve performance. You know, many times it's not about computation. Many times improvement comes from I/O. Many times comes from bugs. I had one customer that was having problems with performance, and they called me and they said, "Oh, we tried to measure the states of the system, but when we tried changing things got worse, and I don't know why, and blah blah blah." And basically, they had some print statements in the middle of some loops, and that's why some things got worse. And so basically, this was a very newbie user. But one thing to understand is that when you measure and try to optimize, you are changing your code, and bad things can happen. And you have really need to know what you are doing. And ideally, we want to design systems that are fast, scalable, maintainable, consistent, tested, documented. Magic land, everybody's happy, and everything works, and okay. And this is how managers see things, you know. I don't want bugs. I want everything to run fast, and okay. But in the real world, we have bosses, timelines. Who here just never had this experience about your boss saying, "I want this in a week," and the project's closed, and they don't bother if your analysis said, like, we need a month? Because they think you are lazy. They think you are like, "Oh, this guy is just getting some time. We can push him to the limit." We have customers that don't understand the difference between when you say, like, "Oh, this won't work in Internet Explorer, so we need another browser," and they say, no, we need this because it's our policy constraint, so we need big companies. So we have technical constraints. In my case, in the pharmaceutical industry, they have really strict regulations about what you should do, what you should use. So we mainly work on Windows, and you know that. Okay. We have social lives, so we don't want to be 24 hours in the office, and we want to talk with friends. I'm not speaking about Facebook or social friends on the internet. So and we are human, and as humans we do wrong stuff. have many bugs. And basically, we are lazy. So it's the human nature. I don't know if everybody can see it. So who here ever experienced something like that? Oh, okay, I know it's an ugly hack, but we'll clear this soon. And okay, this means it's, and it means never. And okay, so I'll put a to-do comment and get to it later, and this means never ever. Okay. And it's kind of annoying when a friend of yours like tags you on Facebook with this picture. Yeah. And you say, oh yeah, I'm getting too lazy actually. And then same friends of yours like tweet something like this. You know? Yeah, I should be testing more. So everybody have a Coshins, you know, that tells you, oh, you should test those functions before getting out of work. And no. And my conscience is very much like that. Yeah. Which means it's a good thing because it has a face. It has a face, and I can talk with it. And it's very clever. So, but everybody here should have one. Like, really. Maybe it's 10 minutes, 30 minutes, but it will like save you time later. Save you headaches. And actually, yeah, I really believe that it's not test-driven development that is pushing the industry. It's guilty-driven development, you know? Because at the end of the day, you should not be guilty. You should not be thinking, oh, tomorrow I'll finish my work. Because many times you won't. People call you with problems, and customers like, oh, we are having this problem, and you forget it. And you can be also better than me, and I suppose you are. But many times it happens. So another real-life example. Oh, don't you comment your code? I can't. It's too complex. And yeah, I think when I read it, I said, oh, it should be like a Pyphi example, you know, when those guys do some crazy stuff, so how do they comment? And if they do not comment, I don't think many of people here can read code on Pyphi project because it's a really amazing project that really selected people can do. And even if you are doing the dumbest code, you go there and read it a year later, you say, who wrote this stuff? And then you see your comment, you know. Oh yeah, this one is about documentation. Okay, so you have your new developer, great, you already know anything about your system? Yeah, I read the documentation. Yeah, it means no. So, you know it's wrong, and you should be, and I see guilty people all around. When I talk to people, you start talking about what you should do, what's the best thing to do, but in real life, everybody says, oh, yeah, I don't have time to do it, but I would like, and these sort of things. And here, you should talk with your bosses, your colleagues, and the people that works with you, and get them involved about it. Because it's about quality of work. It's about not only because you should do it, but because you are trying to make your system more stable, more reliable, and make everybody's life easier, even if they don't understand that, like, you spend 30% of your project writing tests and you don't have anything working in a week. It's fine. They should understand it. And with Python, you have the chance to make things faster because it's really easy to write a prototype that works. Okay. So this is about the background. There's another example I want to give. It's more about it's about how your way of thinking things relates to your work. When I was beginning 10 years ago, we had this database administrator guy, and we were like full of work, and it was a new project. So the boss said, like, okay, it's not too hard. He had to do a little application that collected the information from black box systems, SAM system, do some computation, and do some reporting. And we left him alone. And he was the database administrator, but he had one of these the big company developer certificate, you know. And yeah, after a month, the customer called us and said, oh, the application is really slow, and we really have to wait minutes before it computes everything. And wow, okay, so the guy left in the meanwhile, and we had to look at the code. And basically what he was doing, like, he was asking the information from the system, which was like a big array, a big matrix, basically. And he had to do some very basic computation, like maximum, minimum, medium, and the average, and some a little bit harder. And when we took a look at the database, there was this table named computation_temp. And when there's _temp, usually it's a bad thing. And basically, the application was not written in Python. It was written in Visual Basic. Okay. 6. And yeah, so what he did was, like, he collected all these matrix and inserted in the database everything, then made a select max, select min, and select AVG from the table columns. So all the computation was like from the database system that it was doing. And why? Because the guy was a database system guy. You know, he was the database administrator. So yeah, it's wrong, but okay. Then we saw that also some computations were wrong. And why? Because the data was floating point and the columns were strings. So yeah. Okay. So I like, when I saw it, I said, like, really, never more. Being the developer was not the job of the guy. Really, he didn't do it because he was evil, because he hated the company, but because the boss took a database guy, and said, you had to develop an application. So it's really important for all of us being the developers that we should really know about what we are doing. And optimization should come with tests. Because really want to be sure that after you have optimized, things are running the same way as they did before, just better. So I read many articles about testing, and the numbers are a little bit different, but actually, even if you have automated tests, which can be unit tests, integration tests, functional tests, whatever, you are not going to delete all bugs, because it's impossible. Even if you mix with functional user tests, you will not have a fully 100% unbugged system. So I put the link. I will change the slide later and put it. So don't think that testing will save you all the problems. It will not, but it will help you. So why we should be testing? Because we want regression, quality of work, safety, integration, and documentation. Tests are also good for documentation. And we want tests to be clear, isolated, reliable, repeatable. Because we don't want to go a month later and read the test and don't even understand what the function should be doing. And this is why you should be testing. Oh, can I change its value on a global variable? I don't know. Think so. And then you change and boom. So Python ecosystem, what are our options? We have many, many, many test frameworks. And really it's up to you. Things we really want is standard modules that are easy to write, to run, to change, you test. Want details about what has failed, why it failed, and you want a good documentation because you don't want to spend a week reading the source code. Want to modules that give you information about coverage, profiling, some automated stuff like auto-discovering, parallel tests. You want it to be easy to monkey patch, easy to run tests, and easy to skip tests. So, and the standard is very much the unit test library. And what it gives to you, it gives you a standard way of testing. And if you are coming from other languages, it should be easier for you to get into the way of testing. It's in the standard library. It's most used, so if you have problems, many people will help you. But it's not really Pythonic. This is an example. And personally, even if I've used it in the past, I really don't like very much the syntax. I have to write a lot of boilerplate code to make your test run. And used to have non-specific test selection, test discovery, and some other good features, but Unit Test 2 library came out a while ago, and it improves in some aspects. So personally, I think if you have more developers that have to develop in other languages, and you don't want them to learn each testing library for each language they develop, you can use it. Or if you like the syntax, and you can use it. It's very stable and standard de facto. Not getting too much details because there's a lot of things to say. Questions, save them from the end to the end so we can talk. Duck tests. Duck tests were born, I think it's 1999, something. Comes from the need to, maybe the need to mix the documentation and tasks. Like, we are writing the Duckstrings for our functions, and it's good to have to give examples. So why shouldn't we use it for tests? And that's basically what duck tests do. This is an example of Duckstring and how to write it. And it's very used, it's standard, integrates with docs and tests. And it's a nice thing to have, like, when you have the documentation of your functions, you have all your tests there. So you can, if you change version, you can rerun tests and have the documentation ready to go. It's actually not very flexible like unit tests or the test frameworks. And I put also in the cons that it integrates docs and tests because personally I don't like very much modules with like hundreds of lines of Duckstrings only because I want to put a lot of tests in there. But it's up to me. It's just a personal thing. When I have to debug or to watch the code, I scroll all the lines. Yeah, okay. And Py.test. Personally, I love Py.test because it fits very much more in my brain. It's easy to use, you are ready very quick. You write the test the way you think. You are not having to learn new syntax like unit tests to testing. Like if you want to assert that function has a result, this result, you just write assert, or it's very clean and it's full of nice features. So it's easy to use. Have parallel testing, auto discovery, interact with the bug, coverage, information. You can have profiling information in some plugins. You have a good plugin system. And there's a lot of little features that you can use to write very, very fancy tests. And test framework, Pyphi guys use. Right? Yeah. Okay. So, and they have a really huge test base, you know. So it's very stable, but it's not the standard, and probably not probably, but very much less used than unit test. And if you use integrated IDEs like Wingiti, Komodo, or that brains one, PyCharm, SPI, they have support for unit tests to see on video tests that are passing. Many times you don't have it for I.test. Also, it gives you all very good feedback. You can have HTML feedback from your tasks, a very detailed information, stack information. Yeah. Sort of fanboy. So. And then in the Python world, you have many others. Nose is probably the most famous here. Also Selenium. But go and read go to the link to the Python test taxonomy, you'll see that they have many sections and many are empty. I think because the guy just got bored writing all the test frameworks they have and said, okay, I think really, like, probably you have as many test frameworks as web frameworks. And it's really up to you to choose your tool. But choose it. Because later, when you have to optimize, things get really bad. Some quotations, like, I really like this one. Rules of optimization. Rule 1, don't do it. Rule 2, for experts only, don't do it yet. Nice. Should forget about small efficiencies. Say about 97% of the time, premature optimization is the root of all evil. This is very, very famous. Very, very true. Walking on water and developing software from a specification are easy if both are frozen. Yeah. Okay, so again, I'm stressing the concept that you should be really thinking about what you should do. You should really know what you should do. So when should I think about optimization? Later. And okay, the talk is finished. We can go. My point of view is that you should really be solving your problem first, making a good design of your application, make things work, like a good prototype, getting things working, and also because if you have customers or managers, they really like to see things evolving, and you cannot show the code. So show something that works. Even if it's slow, even if it's ugly, it's better to have them participating since the beginning. They can help you to improve your system, make it better, like with the UI and things like that. Also, you should optimize later, if you and when you need. So basically, thinking about what Alex Martelli was telling us on Monday, it's better to ask for forgiveness. And you wrote a code that is slow, okay, forgive me and I will make it faster. So where should I start from? How many of you have used tools for profiling and measuring the efficiency of your code? Okay. How many of you use Timeit? Okay. How many of you use Superfile or like Hotspot? Don't. And how many of you have ever heard about the project called RunSnake Run? Here have been measured memory efficiency. So here go and measure. Yeah, the links are a little bit small. I will fix it later. Yeah. So RunSnake Run is like a project that helps you to manage all the information you have from Superfile and from I think it should pronounce that, which is a file memory efficiency. And they're really nice. This is a really nice project. And fireside is even more amazing. I love it. And it's a kind of young project made by a guy called, I think it's Luke Macken. And it's an application, a module that lets you inject code in your running processes. So if you have your running Python processes and you want to measure CPU efficiency, RAM efficiency, I/O, and all these sort of things, it will help. And you can inject code and see global the application variables, global variables, the stack. It even lets you inject code and make it run inside the process. Yeah, you can really do really bad things with that. But it's really good for debugging. So use those tools, find your bottlenecks, your issues, and choose a good strategy to attack your problem. You know, anytime it's not a CPU or a computation problem, it's an I/O problem, or it's a database problem, or whatever. Not always a only way to resolve things. This is a picture of RunSnake run, of the showing the melee information. Here you have all your functions, or the bits of code that the units of code that it executes, with some information about the RAM and how it the weight of execution. And here you have a sort of graphical viewable information. To me personally, it's really good. I like to more or less have an image idea of things. I get lost like having the matrix scene of all digits coming down and the information about the processes. And this one is the Superfile one, with the calls there, the number of calls, the average time, the worst time, and all the information you have from the Superfile. And this is a visualization of that. And you can see the parts of your program that are worst performing. And it's really useful because many times you think that you have problems in some parts of your system, but you're not. Because maybe it's called only one time. And then you have this little function that it should be very simple, but it's called many, many, many times. And the cumulative time is what's making your application run slow. And this is a picture from the fireside application. It comes with the 2 version comes with the UI. So you can see the CPU information, memory, reads and writes from the I/O, the threads, and all the open files, the connections that it makes. And here you have all the Python processes running, and you can attach to each one. And yeah, you have the stack information, the object, and with the shell you can interact. Information, and then the call graph, which is really cool. Who thinks it's cool? Or? Okay. You should write a better version. So, what are the options you have to optimize? Well, you can look for the small functions and change parts of your code with better performing substitutes, like replacing loops with map, or like using iterators, or better data structures, like sets instead of lists. But it really depends on what your application is. So a little example, very dumb. Let's define a method that multiplies two numbers. It's in the module called helpers, and then you use it inside your script. Just improve performance. It's really bad, you know. Loops, two nested loops for nothing, and yeah, there's a lot of things you can do. So let's not focus on the unit of measure, but let's say it's executed in 5,000 eyes. And making little changes can improve a lot. Like if I just replace a list with a set and rerun it, 743, which is like 95% better. Yeah, times better. Yeah, times better. So, but yeah, this version, you can say, oh, the list is ordered, the set no is not, but this is made like adding a set and checking taking this check on the set and appending to the list, and both to the list and adding to the set. So we have the same result. A little change can change a lot. And you can try and also other changes. Many times you should remember that everything in Python is an object. Everything in Python is a dictionary. Python is dictionary based. So every time you have a lookup, variable lookup, if it doesn't find a variable in the local scope, it will try to search it in the global scope and on the modules and so on. So it will take time. So if you reduce the lookups, like place this lookup with saying like HM equals to helpers.mul and res app equals to res.append. It will reduce a little, but it will reduce the time. And it's only changing on two variables. So you can still scrape the bottom of the bottom. So, and you can try with iterators, with placing map function, generators, and doing a lot of work on your code to make things better. There's a lot of space to improve performance. Okay, so if you don't want to spend too much time on that, you can have a really fun, happy time writing extensions like in C or C++, and then use it from the Python application with like a Python API, with C-type, Python, Boost, Sweet, and there are other options in other languages. Or or like you could also like delegate computation and to other processes running on other servers and using what you want, like pipes or whatever to you can parallelize, and so you can use like stackless, libevent, greenlet, gevent, eventlet. Or if you are doing web stuff, you can use Celery. You can use one of the multiprocessing libraries. And rely on the GIL. And you can ask about the GIL and the GIL wars and stuff. And you can also use concurrent.futures. How many of you have ever used threads in Python? How many of you like it? Results about threads in Python? Okay, that's one. And sometimes it works, but you have many problems about the real threads and Python threads and the context switch between threads and all this stuff. And the multiprocessing module is really nice and can give you many good things. But there's this new module, which is, I think it's part of the standard library in Python 3. You have it for free in the Python 3.2 version. We are working with the Python 2.7. I don't know if earlier version works, but you can use the backport of concurrent. How it .6 works. Okay, thanks. And so I prepared some slides about concurrent.future because it's a really new thing in the Python world. But then I saw the conference schedule, and Andrew Dolk is going to talk about concurrent futures tomorrow, so you should go if you care. Or if you want to learn more about those little improvements you can do in your code, you can go out of this room and go to the training session right there by Mike Mueller, but he's doing another training session, I think. Or go to his talk about Python is faster than Fortran. The only thing I want to show you current is the PEP 3148 that talks about it, and basically it's saying that Python have many powerful primitives and constructs to build rather than multi-process applications, but they are hard to use, not really easy to understand. So concurrent futures is the way to simplify things and make things work better. Not work better, but easier to use. And basically handles all the threading and processing, synchronization, and using the right data structures. It does basically the pickling of the objects for you, and you can simply define the maximum of processes and threads you want, and it helps you to make use of multiple cores, which is another thing that many people complain about Python. And Multicore is another thing that is very discussed, and if you want to use multicore course with your Python applications, personally, I do prefer to like write small applications instead of one big application that do a lot of stuff. So your system is more reliable because you know what services is going down when if it's going down, and each process uses its own CPU, so you don't face many of the problems you have. This is multi-threaded programs. Joke, you know. Oops. And basically, many times you have many threads and a thread like fail and they're there and don't know what's happening. It's really hard to debug multi-thread applications. Really hard. So as I said, you can parallelize. You can also parallelize in many other ways, not only with those techniques. Like if you want, you can use delegate to other machines the computation. Like you can have execnect is a nice module that lets you execute code remotely and give you back the results. It works also with other Python implementations, not only CPython. And you can use PyCloud, which is a web version of it. And you can also use cache techniques to improve performance. But I won't talk about that because there are too many ways to fail there. And if you're doing simple cache, you can go, but doing big caching systems is really hard. There are some projects that you can use to it, or like many recipes on online about caching. So and you can try also other implementations. Many times other implementations do things faster, or like if you can use Jython to get the Java libraries that do some stuff and do well, or C EuroPython to use .NET libraries. Sometimes they are faster. And I forgot. Yeah, and you can use Pyphi. Make things go faster, you know. So all the work we did before, trying to optimize things. Here, the number you see here is the number you have executing with CPython. The number there that I didn't talk about is the number you have with Pyphi. Out of the box, download Pyphi, run with Pyphi, and you have all these things. And basically, it's doing the same thing, but much better than you can do. Rigo, Antonio Cuni, and a lot of very clever guys did a lot of work. And it really improves performance a lot, many times. Not always that way. You can go and check what's the called Python performance website, I think. But basically, will translate many of your code to better performing code, and we will run it. Very stable. It's ready for production in most of cases, and if you are running code that use C libraries or rely on external modules and these sort of things, you probably cannot use Pyphi yet. Try. There's some support for C libraries. There's support for C types. And if you're using Python 3, wait. They are working on it. And how many of you are using Python 3? Okay. And Python 3 for production? Okay. Yeah. Like 1%. And it's a good percent. So my conclusions are that optimization should come from real needs, and very often optimization comes with compromises. If you change your code to make it faster, many times it's less readable, it's less flexible, it's less maintainable, and many times it's not on computation, so you have to really understand what you're doing. If you are having I/O problems with performance, there's still stuff you can do, but it's not that much. For instance, if you will have like 1 gigabyte file, very big file that you have to parse, and you have to like do it fast, you can split it on n parts and parse each part and then glue together. But it won't be as readable and easy to maintain as the code you were using, parsing all the file. And try always to keep your project and your schedule focused. And because if you start optimizing at the beginning and you have schedule and you just lose a lot of time optimizing, you lose your focus, your project will fail. It's better to like deliver a system that is low, that deliver anything at all. And I forgot to talk also about if you're doing mathematical stuff, there are a lot of ways to improve it. There's NumPy, SciPy, and many other mathematical libraries. There's but there's a lot of stuff. And really, before optimizing, you should really search on the web and look for what other people are doing. Python gives you many options and tools, but the approach is really important, and it's really up to you. You have to have control on your code, on the stuff you're doing, because if at some point you look at your code and you say, "Oh, I can't even understand what I did," or "Wow, it's fast, but I probably won't touch it like in the next 10 years." It's not a good thing. Thanks, and
thank you very much.
Time for questions.
Time for questions. Anyone have a question?
Early on, you mentioned that the built-in unit test module has a lot of boilerplate that you think gets in the way. But I mean, it seems that once you start writing any sort of non-trivial test suite, that boilerplate stops being boilerplate and starts being sort of critical. Do these other test modules or test packages you suggest, do they have all the fancy, test parameterization support and test generation support and all the sort of complex stuff you might need that you can get from unit test?
Okay. Yeah. Basically, the answer yes. Like in my case, I started using py.test because it's had many features that unit test didn't. Like especially the test skipping and test selection, auto-discovery, and all these sort of things. And it's really easy, like, to write config files. Okay, it's not that easy, but once you like learn how to do it, it's easy. And to write config files for your tests that are running, and so you can use them. And it's not so easy to customize tasks and task running with unit tests. Unit test 2 is much better, really much better. Michael Ford did a great job on it, but I'm giving options to you. I'm not really saying you should use py.test instead of unit test, because it's a lost war, like Emacs and Vim. It's up to you, really, and up to your team. So personally, I like really a lot py.test, but unit test is good. It's really good. And Nose is good too. It's very used in the web world. Many people write in Django or Pyramid applications, Flask applications use a lot of Nose. But personally, I've never used it. But looking at the documentation and talking to people, they are very happy with it. So.
Anyone else?
I actually have two questions. The first one is about the fireside profiling tool.
Mm-hmm.
I didn't know about this tool, so I'm asking, how does it work when you have C extensions? I mean, it is able to measure even the time spent and the C part, or only the Python part?
Oh. I never use it on C extensions. But theory should give you the stack information on the calls on your C extensions. And I think it depends very much on how you're extending. You're using like C types or Cython or whatever. Actually, I really don't have a exact answer for this question, but I think at least it will measure your calls and the time spent on calls. Yeah. Second question?
Do you use Pyphi in production?
Production? Yeah. Not so easy. No, yes. But it's like since weeks ago. Okay, so, and it's not delivered yet. It's on because when we deliver software, many times we have when we have 1, 2, 3 weeks of things running and other people testing their stuff and so on. So it's running, and it's running faster, it's running well. So yeah, I have it, but it's kind of a new feature of ours. Yeah, but you should be doing it.
Anyone else?
This is related to Pyrosite too. So you say you can attach Pyrosite to a running Python. It literally doesn't require any sort of code in the program itself to open a port or something like that. It can purely attach.
Yeah.
And what about? So this is also related to embedded stuff. What if I have an embedded Python process or an embedded Python runtime in a C++ program? Can I attach to that as well, or does it depend on Python being the top sort of executive level?
I don't think so, because you're not exposing your Python process. It's embedded on the C on the main process.
Okay.
No.
It makes you wonder how they attach it in the first place.
Yeah,
then.
it
So,
depends. If you're
okay, so anything with sort of an embedded libPython, it might work. Okay.
yeah. If GDB can attach to
Yeah,
it,
it uses GDB to attach to it. So even for your C++ Python constructions, it might even work.
What version of GDB?
7.3 and higher.
Thank you. Yeah.
Thank you.
But it also depends if your embedded process, how it behaves. You know, if you are like spawning and killing, it's not good.
Anyone else? All right, then thank you very much,
Sure.
Fabio.
Thank you.
Thank you.
Grazie. Non è stato troppo generico. Avevo paura. No, anzi. Però sta cosa qua è strafiga, riesce a capire.
Ma una cosa, ma te non ce l'hai mai avuto?